with Franz Vollmann. He is the head of the Printed Electronics program at Hereas, and they're developing a very interesting approach, combining their particle-free inks with an inkjet printed process. And one of their very interesting applications is in conformable EMI shielding for semiconductor packages. And this is the topic of today. So over to you, Franz.
Thank you, Kasha, for the introduction, and thanks for the audience to pay attention to the presentation. Let me quickly jump into the topic. We're talking here about the EMI shielding of semiconductor packages and a system solution that Hereas offers that consists of a material, that consists of the printing equipment and the curing equipment, as well as the process behind it. That offers, on one hand, technical and functional advantages, such as a very high shielding performance that ranges not only from the sub-gigahertz range, but it goes up to the millimeter wave range between 20 and 40 gigahertz, and I'll show you data later on that, with a very thin coating. It offers you the advantage of selective shielding or partial coating, in a sense that you can do that in a digital way, which means just by changing your print picture digitally, you can change right away the area where you shield. There are also commercial advantages. There is up to a 25% lower total cost of ownership, and that's compared to an existing solution like sputter. The savings against the traditional cages or a gasket solution would be by far higher. We have a factor of up to 3 higher process speed compared to sputter, and then also less capex and a smaller footprint on the equipment portion, which I'll show you later. Now, let me just jump into it. The Hereas system solution, when we looked at the market, we saw, and I think in the presentations today also, we see some suppliers that would offer a material, some that would offer more on the equipment side. We clearly saw the need from a customer point of view to have a supplier who integrates the material, the device or the equipment, as well as the process. So therefore, our solution is a system solution, a material that would be the silver ink, the inkjet printing and curing device, and the process behind it. What we're talking about here now is Hereas expertise in metal organic decomposition inks. We're producing metal organic inks already for 15, 20 years that were used in the past in the decoration field. We have a separate unit that is expert in the curing area, in curing lamps and processes, as well as systems. And we've brought in the inkjet printing know-how to build also inkjet printing equipment to go with our inks and with our process. Substrate is obviously something that is usually defined by the customer, and therefore we're not a substrate manufacturer. What do the advantages on the commercial side, but as well as on the functional side, really offer to the community, to customers? It does reduce the complexity, as it's an inline solution that you can use right away in your manufacturing process. It's a system solution, so you don't have to, as a customer, combine the ink or the material with an equipment, with a process. You have a much higher degree of freedom in your design because of the ability to do partial coating, because of the possibility to change also and to customize your designs, given the fact that you use a structure that uses a very thin layer of silver. You do save in terms of space as well as in terms of weight. Any design change can be done digitally, so there's no need for either developing or designing a new masking tool and other things and lead time and cost involved. You can easily scale. It's the same whether you produce one part, 1,000 or 1,000,000 parts, and you have also a cost advantage. What are the various components of the Hereas system solution? Number one is the Hereas particle-free ink. To understand and to distinguish it from a nanoparticle ink, an MOD or metal organic decomposition ink is particle-free. So you basically mix the metal precursor in a solvent with a complexing agent and have then a metal organic decomposition ink that is directly filled into your inkjet printing